and he's going to be talking about chrome replacement repair efforts at Honeywell. And so with that, Eric, I'll let you control the screen.
You can hear me, right, guys?
Yep.
Okay, great.
And your presentation looks good to go.
Okay, awesome. Okay, so as Vic mentioned, I'll be covering chrome replacement repair development using high-pressure cold spray at Honeywell R&L. My name is Eric Przybylowicz, and I'm a materials and process engineer here, and I just started working on this program towards the end of last year. Oh, hold on. There we go. So here's a brief agenda of what I'll be covering. I'll give you guys a brief introduction. I'll cover some background on the chrome replacement program qualification at Honeywell. I'll give you some background about the cold spray activities we do here at Honeywell. We'll cover some spray activities at the Army Research Lab as well as confirmatory spray activities at Honeywell. I'll give you a brief summary of the qualification testing as well as outline the remaining steps for production readiness. So a brief introduction, cold spray remains a core technology at Honeywell R&O. The Phoenix Sky Harbor site has both low and high pressure capabilities. We have a VRC Gen 3 system which was recently installed here and several centerline systems. We currently repair over 160 different part features covered by more than 60 approved repair documents. Some of the typical features are seal surfaces, housings, flanges, and currently those approvals are limited to non-structural applications. So we haven't approved any structural applications in production yet. These cold spray repairs are performed both at Honeywell as well as using external suppliers. The supplier approval is specific to both powder composition, manufacturer, and base material, and we provide these authorizations through overhaul repair instructions. Right now, our cold spray approvals in production include aluminum and aluminum oxide, commercially pure aluminum, as well as Inconel 625, and we apply that to both aluminum, magnesium, and titanium alloys. So the chromium replacement program qualification at Honeywell, we are participating in the joint test protocol to replace chromium and nickel plating due to, sorry, 1 second, due to hazards associated with these plating processes. This covers multiple substrates, powders, gases, and a variety of other things, but the focus of this testing will be on one part number and the associated lug shear evaluation of that part number. You can see here that part's the low pressure compressor shaft, EGT 1500 engine.
Hey, Eric, whatever you just did a second ago when you coughed, it might have shifted your mic. We can't hear you now.
Okay, how's this?
Yeah, that's much better.
Sorry about that, guys. It was down by my chin. So as I mentioned, the part is the low pressure compressor shaft. It's composed of 4140 steel, which has been normalized, quenched, and tempered. This part is chrome plated per AMS 2406, and one of the unique features of this is it requires an 8 RA surface finish, so we wanted to see if we could achieve that on this material. As I said before, the work scope includes spraying coupons to support lug shear testing, as well as spraying a scrapped shaft to show that we could meet the surface finish requirements of the drawing. Getting into some of the details here, 2 different spray parameters were evaluated using the same bond coat and top coat. You can see here it's the BC1 as the bond coat and the C1 as the top coat. They were sprayed using the VRC Gen 3 system using a nitrogen gas. You can see here the parameter changes relative to ARL and Honeywell. These were motivated sorry again, by HS&E or health and safety issues at Honeywell that forced us to reduce the temperature. The trade-offs in the pressure and the RPMs were made in an attempt to maintain the properties of the deposit with that trade-off in temperature. So you can see here are some images of the coupons before and as sprayed here on the right, and the shaft here at the bottom with the maskings and the as-deposited cold spray in those 5 locations. Here's a quick slide to show the machining of those samples after they were returned back to Honeywell. At the top you can see the lug shear specimens that were fabricated after spraying, and at the bottom you can see the shaft that was successfully ground down to the required surface finish. So here's an illustration of the lug shear testing that was performed. On the left you can see a schematic of the fixture with the sample assembled in it. The center photo here, there's a retention bar which holds the carbide that shears the lug. It's been removed so you can see both unsheared cold spray lugs there. And then in the right photo you can see one of the lugs has been sheared. The sample has been flipped in order to shear that second lug. Okay, now into some results. So these initial results are a product of the spray activities done at ARL using both the Honeywell parameter set and the ARL parameter set. You can see here all of our properties exceed our targeted range of 20 to 30 KSI. One important thing to note here is there's a slight elevation of the first 3 Honeywell tests. This is likely due to an increased displacement rate that was used during these first 3 tests and was corrected for the final test. Evaluation of these samples, I provided a representative image of the Honeywell shear surface, as well as some micros of both the Honeywell and ARL parameter set. You can see the fracture occurred primarily through the cold spray deposit adjacent to or along the interface. We noted satisfactory bonding with no excessive voiding or oxide contamination. There was also significant material mixing at the interface, and we haven't noticed any marked differences in the cold spray deposit microstructure between the 2 spray parameters, but we're actually still doing some additional investigation there. Moving forward, we brought more coupons down to Honeywell and did some confirmatory spray activities here using only the Honeywell parameter set and identical spray fabrication and testing processes that we employed for the sample spray to ARL. You can see here the lug shear test results from that. We were able to achieve an average of 54 KSI, which is, again, in line with what we had seen from the sample spray to ARL that were tested at the appropriate displacement rate. And you can see the fracture surfaces here and an example of this section that was taken on the next slide. So very similar to what we saw before, this is the cut-up and evaluation of the samples both sprayed and tested at Honeywell. Here are those 2 samples that you saw on the last slide. So very similar micrographs to what we saw prior. You can see really good mixing there at the interface. And again, it's sheared in the same manner as the prior samples. So here's an overall summary of which parameters were used and what was tested at the top. You can see the parameter IDs, the nozzles used. There is a slight difference in the nozzle used between the Honeywell and ARL parameter set, and this was more selected just due to what we had on hand. The shear test results provided at the bottom were all deemed to be comparable. We pulled out the samples that had the increased displacement rate and averaged the 2 parameter sets. You can see they align very closely with the Honeywell average being slightly higher. Okay, so what are the next steps? So the remaining steps for production readiness to apply this particular solution to this particular part number are to finish some of the analysis we're doing associated with the microstructure of the cold spray material. We'll then be submitting that to ARL and the Army for approval. Following that, we'll have to create a repair instruction to authorize the application of this cold spray on the part number. We'll then, as I mentioned before, because we control all of our approvals by powder, manufacturer, and base material, we'll need to include those applicable items into our approval system and process the initial part so we can begin routine production. So really quickly, I'd like to give a shout out to Bruce Almond, who championed a lot of this work for more years than I know, who retired recently, earlier this year, as well as Billy Simmons here at Honeywell, and then Vic, Isaac, Aaron, and Matt for helping me through this work. So it looks like I have a good amount of time for questions. So I flew through that.
Thank you very much, Eric. That's very telling data that you've shown in terms of shear strength. And so one of the questions that came in, and I'm not sure you're going to be able to answer it. So the question is, in regards to the shear strength values, you know, how does that compare with the chrome plating? And I mean, I know from experience that you're not going to be able to do the triple lug shear test on chrome plating. So I don't know if you have any data in regards to chrome plating adhesion.
So we don't, and this is something that actually came up early on when I started working on this program, and we had looked into, we had decided to set a bar for ourselves of around 30 KSI, but again, we aren't able to do, I guess, like you said, replicate this test with chrome plating. So no, I don't have a straightforward answer for that.
Yep. And what do you see the target platforms for the chrome replacement? That was another question.
Right now, we're focusing on DoD parts as a part of the agreement we have with VRC and ARL. So we're primarily looking at
Yep.
the AGT 1500, T55, any military parts where we can replace current, I guess, chrome repairs that are for dimensional restoration, or you know, like sealing surfaces or wear surfaces and things like that.
Right. And there's one last question, and you know, and this is probably, I don't know if you can quantify this or not, but the question is, you know, comparing adhesion values of low pressure to high pressure. Are there differences?
So we didn't, I haven't been a part of adhesion testing using the high pressure systems yet, so I guess I can't speak to that specifically from my own experience. My assumption would be yes.
Yeah. Okay, appreciate it. We're going to stick to our schedule. Thank you very much, Eric, and for your participation. And with that, I'd like